All right, we have been working with approximating square roots and cube roots, making estimates and different things like that, getting kind of close to the answer, but not worrying about the exact answer or that it's written just perfectly. So we're going to do something a little bit different today. We're going to be writing down the exact answer, and the exact answer many times with a radical has a radical in it. So what we're going to do is we're going to talk about simplifying square roots. So the I can statement is I can simplify square roots and leave them in radical form. Okay, and sometimes we'll call radical form, we'll call that exact form. So I'm just going to write that over here, exact form. All right, so the answers that we get today, they may not look great, but they are in what we call exact form or radical form. So in the warm-up part A, it says in the problem 3 squared equals 3 times 3. Squaring changes one base factor into a group of blank factors. So take a look here. We've got this exponential expression. We've got the base is 3 and the exponent is 2. And what the 2 tells us is we're going to take this one 3 and we're going to turn it into 2 3s. That's what an exponent does. So squaring changes one factor into a group of 2 factors. Okay, next question is what is prime? Hopefully you remember what a prime number is. A prime number is a number that is divisible only by 1 and itself. Okay, so I'm going to put number divisible by only 1 and itself. Okay, a number that's divisible only by 1 in itself. And then you may have done some prime factorization, some factor trees and different things like that. So what we're going to do is we're going to prime factorize each one of these. Now here's how it works. You can take 18, and what we do is we draw some little branches off there, and you can think of any two numbers that multiply to be 18, or think of a number that goes into 18 and then figure out how many times it goes in there. So I'm going to start off with this. I'm going to start off with 2 goes in there 9 times. So at each one of these branches we should be able to multiply them and get the one right up above. So 2 times 9 is 18, and then 2 is a prime number, so we're going to stop right there. And then we're going to break this down. So 9 is a 3 times 3, and we end each one of the branches at a prime number. So this is a 2 times a 3 times a 3. So 18 is 2 times 3 times 3. That's how we would write the prime factorization of that. If we were doing 12, let's say you did 4 times 3. 3 is a prime number, but 4 isn't. We can break that down. So we would have the 2, and the 3. So I'm just going to go ahead and write that down as a quick little list. 75. Let's see. 5 definitely goes in there, but a lot of people might do something like this. 3 and 25. And then this would be 5 and 5. So I'm going to write down 3 times 5 times 5. And then 48, let's see. If you can't think of anything that goes into 48, or two numbers that multiply to be 48, recognize that it's even. If it's even, 2 will go into any even numbers. So we could do 2, but some of you might be thinking, oh, maybe 4 times 12 or 6 times 8 or something like that. Either one of those would be fine. So I'm going to do 6 times 8. If I do 6 times 8, neither one of those are prime, so I'm going to break this down. That would be 2 and 3. 8 would be 2 times 4. And 4 would be 2 times 2. So take a look at what we've got here. We have this, instead of these nice little trees that we've got here, this is just a bunch of sprawling branches and everything. And we're going to write down, just like we did on these other ones, the very end of the branches. So I'm going to recognize that I've got that many 2's. So I've got a 2 times a 2 times a 2 times a 2. And then I've got a 3. Now notice I've got all of the ends of the branches taken care of. So that is the prime factorization for 48. And then if we were to do 10, you probably would do 10 times 10, 2 and 5, 2 and 5. So I'm going to write those down together. And you'll see why it's a good idea to write them down together in just a minute. So that would be the prime factorization for 100. Now, we've talked about this before. A lot of what we do in math is we learn how to do something and then we learn how to undo it. And when we undo it using an operation, we call those inverse operations. Inverse operations. Taking the square root is the inverse of, you could probably guess, is the inverse of squaring. So if squaring changes one factor into two factors, like we mentioned up above, like this problem right here, squaring takes that one factor and turns it into two factors, then taking the square root should do the exact opposite. It should take two factors and turn it into one factor. Okay, so hopefully that reasoning makes sense, and then we're going to show you some examples here. So when we look at this next group of problems, I realize these are all perfect squares, and we already know how to solve and find square roots of perfect squares. So go ahead and write that down. We already know how to find square roots of perfect squares. Taking the square root, though, we're going to do these again, and we're going to think about it this way. We're going to think about it as far as the square root changes a group of two factors on the inside of the radical into one factor on the outside of the radical. Okay? Now, this is going to seem weird because you might look at this and go, oh, well, I already know what the answers are. I can just write them down. But if you'll follow along with this thought process, it's going to make the other problems, like the ones down here, a heck of a lot easier. Okay? So I want you to notice what is left inside the radical after we take the, and we're going to be looking for, so write this down, pairs. Pairs are going to be a big deal. Write down pairs of factors. So what's left inside the radical after we take the pairs of factors out? That's going to be really important for simplifying these. So if we take a look at the square root of 1, I'm going to write it like this. We need two factors here. 1 squared is 1. So we're going to take this pair of factors on the outside, and we're going to represent it with 1 on the outside. So if you've got two factors on the inside, you're left with one factor on the outside. And think about what's always left as part of a multiplication problem. You can always put a 1 as part of a multiplication problem. So we could have the square root of 1, but that's kind of going around in circles. So 1 times the square root of 1 is 1. Okay, so there's our answer right there. Let's take a look at this one, and we'll warm up here. So 25 is 5 times 5. So 5 times 5. Now, I'm going to throw a 1 on there because 1 can be part of any multiplication problem. And the square root takes a pair of factors on the inside and turns it into one of those factors on the outside. So we've got a pair of 5s on the inside. We're going to write a 5 on the outside. And then what's stuck underneath is the radical 1, but that's just 1. So the answer is plain old 5. Now, again, I know this seems like a roundabout way to do it, but believe me, it's going to make things a heck of a lot easier. What I do want you to notice is this process works, and it gets the same answer as we did before. So we know the answer on this one's going to be 7, but let's think through why. Because 7 times 7 is 49. We square 7 to get 49. I'm going to put a 1 on there, and I'm going to take out a pair of factors on the inside, turns it to one factor on the outside. The thing that's stuck underneath is the 1, but the square root of 1 is 1, so 7 times the square root of 1 is 7. Again, weird, I know, but take a look. 9 times 9, put a 1 underneath there. We've got a pair of 9s, so remember, a square root takes a pair of factors on the inside and turns it to one factor on the outside. So we're going to have a 9 on the outside, a 1 stuck on the inside, and 9 times 1 is 9. And then the last one, of course, this is going to be 12 times 12 times 1. Pair of factors right here. Got a 1 left, so the answer on this one is 12. Silly way to do those problems, but take a look at the next one. Okay, so everything up above works out really well. Okay, the problems below are a little bit more difficult. Okay, these are not perfect squares. Okay, that one is, but we'll deal with that one in just a second. So it turns out we're going to do exactly the same thing. We'll just have some factors left inside the radical. Now remember, up here we had a 1 left in there, but the square root of 1 is 1, so that didn't matter. So we're going to write these in what we call exact form instead of giving an estimate. We've actually done a couple of these before and just given estimates for them, but here's the right way to do these. Now this is the square root of 18 and the square root of 12 and the square root of 75 and the square root of 48. Now you may recognize these numbers. Take a look up here. We already factored those. Okay, so I'm going to shrink this down so we can have this on the page so we can see it. Okay, so I'm going to write down the prime factorization. This would be the same as writing the square root of 2 times 3 times 3. Do this next one. This would be the same as writing down the square root of 2 times 2 times 3. For 75, it would be the same as writing down, and again, we did all this work up here, so 3 times 5 times 5. 48, This was 2 times 2 times 2 times 2 times 3, all of those underneath the radical. And I know we've already figured this one out, but I want to take a look at it this way. 2 times 2 times 5 times 5. Okay, now I'm going to go back to this a little bit bigger size here. And remember, what the square root does is it takes a pair of factors on the inside and turns it into one factor on the outside. So this is a pair of 3's. So we're going to represent that pair of 3's on the outside with just one 3. And then my question for you is, what's stuck underneath? Well, the thing that's stuck underneath is the 2. Okay, there's nothing to pair it up with. If there was something to pair it up with, we'd take it out. Okay, but there's not. So this right here is the answer. We're done. That's it. So let's take a look at this one. Same idea. We're looking for pairs of factors. So here's a pair of 2's, and this is why we wrote them in right next to each other in the order that we did. So there's a pair of 2's. If I've got a pair of 2's on the inside, I've got 1, 2 on the outside. The thing that's left here is a 3 because there's nothing to pair it up with. So the answer on this one is we say 2 radical 3. Next one. Square root of 75 is the same as square root of 3 times 5 times 5. There's a pair of 5's, so we put a 5 on the outside, and what's stuck underneath? The 3. And again, the reason it's stuck underneath is because there's nothing to pair it up with. Okay, take a look at this next one. We've got 4 2's and a 3. So we're looking for pairs of factors, remember. We're looking for groups of 2. So I'm going to group those two together. So this is going to be a 2 on the outside for that one, and another 2 on the outside for that one. And then what's stuck underneath is the 3. Now we normally wouldn't leave it this way because on the outside, if it was multiplication on the outside, or sorry, on the inside, it's going to be multiplication on the outside. So we'd normally do 2 times 2 is 4 radical 3. Okay? And that's the way we'd say each one of these answers. So the exact answer to radical 18 is 3 radical 2. The exact answer to radical 12 is 2 radical 3. The exact answer to radical 75 is 5 radical 3. And the exact answer to radical 48 is 4 radical 3. Now, this one you should recognize. We've done this one several times before, the square root of 100. We know the answer is 10, but I want you to take a look at this and see how well this works out. That is a pair of 2's, and that is a pair of 5's. So a pair of 2's on the inside means I've got 1 2 on the outside. Pair of 5's on the inside means I have 1 5 on the outside, and technically it's a multiplication problem, so what's left? There's always a 1 left. So we have a 10 on the outside times the square root of 1, which is 10. Same answer either way. Okay, so that's how you simplify square roots. Now we did all of those above with the prime factoring. If they're not already factored, then you have your work cut out for you. So here's what we're going to do. I'm going to take this number and I'm going to do 5 times 9. We're going to prime factorize this. Okay, and then I'm going to write it down as 3 times 3 times 5. Pair of 3's, 3 on the outside, and again, what's stuck underneath? The 5. And again, at least think about why it's stuck underneath. The reason it's stuck underneath is there's nothing to pair it up with. Okay, this one's kind of interesting. This would be 8 times 4, which is 4 times 2, which is 2 times 2, and that's 2 times 2. So take a look at what we've got here. We've got the square root of 2 times 2 times 2 times 2 times 2. 32 is actually 5 2's. So let's pair them up. Pair of 2's, pair of 2's. So there's a 2 and a 2 on the outside. One for this group and one for this group. And there's a 2 stuck underneath. Now again, think about why this is stuck. Because we took out all the other pairs, there's not something else to pair that up with. So we multiply those numbers out front together. We get the coefficient of 4 radical 2. Okay? All right, let's take a look at this one. The numbers, if they get bigger, they can be kind of tough. So let's take a look at this. Think of this in terms of like $1.75 or something like that. How many quarters would we have if we had $1.75? If we had $1.75, we would have 7 times 25. Now, if you want to double check that, let's just do 7 times 25. Whoops. 7 times 25. We do get 125. Or you could take 175 and you could divide it by 25 and figure out that it's 7. Or if you know it ends with a 5, you could start off and just factor out a 5 and then go from there. That's going to be 5 times 5. So we have 5 times 5 times 7. Pair of 5's. Those are on the outside. And again, what's stuck on the inside and why is it stuck on the inside? There's a 7 stuck on the inside because there's nothing to pair it up with. Okay? All right. I'm going to do 9 and 10 here. 3 and 3. 2 and 5. And we haven't run into one like this before, so take a look. Pair of 3s. Is there any other thing that we can pair up here? There's not. So that means we have a 3 on the outside and a 2 and a 5 on the inside. Now, just like we do on the outside, these are multiplication problems. So the easiest way to write this would be 3 radical 10. Okay? And that's it. All right. Let's take a look at this one right here. Now, I'm going to do the same thing I did here. That one ends in a 5. In fact, you know, like $1.75 or something like that. This is like 225. So let's see if we can get 25 to go in there. 225 divided by 25 goes in there 9 times. Now, some of you may recognize this, and let's see if we get the same answer that you think it is. Okay. In fact, this is kind of convenient. I'm just going to do this. Okay, they all ended on the same level, so I'm just going to put a bar over that. So a pair of 3s and a pair of 5s. 3 on the outside, 5 on the outside. Again, what's stuck underneath? Okay, we could write a 1 if we need to, but a lot of times if there's nothing left, we just get used to the fact we just don't even write the radical anymore. So we've got 3 times 5 is 15. And that should be one that you have memorized, or at least recognize that that's on your list. So now we'll take a look at the worksheet and let's do problems 1, 6, and 7. So I'm going to flip over here. We're going to look at number 1, number 6, and number 7. So here's number 1. Slide down here. Here's number 6. And here's number 7. Okay? So here, this would be the best technique for this. I know you've probably seen some of these before, but it would be a good idea if you at least tried these on your own. So pause the video for a second and then watch how it's done. Pause the video again and then watch how it's done until we get done with all 3 of these problems. So go ahead and pause, and then I'll go ahead and do this problem. This is 3 times 4, which is 2 times 2. And if you can immediately go to right here, that's awesome. Okay, pair of 2s with a 3 stuck underneath. Okay, we'll slide down to number 6. Same thing if you want to pause for a second, and then I'll do the problem. I'm going to think 9 times 8, which is 3 times 3, which is 2 times 4, and that's 2 times 2. So here's what we've got. A 3 for that one, a 3 for that one, a 2 for that one, and if you have to, go ahead and circle those and then cross them off as you do them. Okay, and then another 2. So we've got a pair of 2s here, sorry, pair of 3s, pair of 2s. So a 3 and a 2 on the outside, and then think about what's stuck underneath. There's a 2. So the simplified answer, again, we want to write things as simply as we possibly can. That's going to be 6 radical 2. And number 8. You can pause the video, give you a head start, and then I'll do the problem. This is an even number, so 2 goes in there. So I'm going to grab the calculator and just double check and make sure I know how many times 2 goes in there. So we're going to do 104 divided by, sorry, that's 108. 108 divided by 4. 27. So we're going to do 108 divided by 2, and we get 54. So I'm going to put a 54 right here, and then I'm hoping you could do that one in your head, but if not, it again is even, so we're going to do 54 divided by 2, and we get 27. Okay, so 2 goes in here 27 times, and then we should be able to finish this off because this should look familiar. That's 3 times 9. And that's 3 times 3. So again, this is going to be the square root of a 2, whoops, not that one, a 3, and a 3. Okay, so make sure we're at the end of each one of those. We've got each one of those represented. So we've got a 2 on the outside from that pair, a 3 on the outside from that pair, and then a 3 stuck underneath because there's nothing to pair it up with. So we end up with 6 radical 3. Okay, That should be enough that'll get you through your assignment. All right, good luck.